Okay, so this is what we're going to do today. We're going to look at the sum and difference of cubes. Do you guys remember when we learned about difference of squares? Remember we had this thing? And in the difference of squares, we would take like x squared minus 81, and we learned to factor that down to x plus 9 and x minus 9. And the real formula for that was a squared minus b squared equals a plus b times a minus b, right? And you had to take the square root of a squared to get a, right? So that's how you went from like this to this. So the square root of x squared was, was x, which is what you have here, right? And remember, you were taking the square root of 81, and the square root of 81 was 9. You know, there was no, you can't take the square root of a negative. It's not a negative. It's a subtraction of an 81, that kind of thing. Okay, so this is going to be similar, but this time we do not require the negative, and this time we're going to look for perfect cubes. So this difference of squares only worked when we had perfect squares, but now we're going to look for at cubes. So before we get too far, what is 2 cubed? 8. 3 cubed is 27. 4 cubed is 64. 5 cubed, 125. 6 cubed, anyone? Bueller? All right, 6 cubed is 216. 7 cubed is 343. 8 cubed. 8 cubed I think is 512. 9 cubed, 729 as I recall. And 10 cubed, we should all know that one, is 1,000. Okay, so these are our perfect cubes. So these are the numbers we want to be on the lookout for. Okay, now, the only other thing that's worth mentioning is, can you take the cube root of a negative? Yes, you can. It's -2. Because remember, for goodness sakes, if we cube a negative, -2 times -2 is +4 times -2 is -8. So don't forget that you can have negatives floating around in these because of that little situation. Okay, so let's look at it. These are going to look something like this. We're going to have something like x cubed plus 8. Or maybe we're going to have 8x cubed minus 27. So in all of these situations, we have perfect cubes. Now, at the beginning of this, we said this is called sum and difference. And look here. Here's a plus, and here's a subtraction. Totally okay. We have a formula for both of these. So let's look at the formula. I like to build the formula. So our original formula starts like this. Okay, so I like to build these. So our original formula looks like a cubed minus b cubed. This is for difference of cubes. And it's going to look something like this. Actually, they both look really similar. So it's going to equal 2 brackets this time, a binomial and a trinomial. And it's going to look like this. A squared, AB, b squared. Now, I've left out the operators, like the plus and the minus, and here's why. This is negative, so this is subtraction. So there's this fun little thing we say SOP, S-O-P. So S stands for same. So we had subtraction over here, we're going to have subtraction here. O stands for opposite. The opposite of subtracting is adding, and P stands for plus. So here is the formula for difference of cubes. Okay, sum of cubes is also a thing. So sum of cubes looks the exact same, but we're going to add. So a perfect cube A plus a perfect cube B is going to factor down to the same. We're still going to go A, B in a small bracket, A squared, AB, B squared. So you can see like the pattern is the same. A, B, B, A squared, AB, B squared. Now we're going to do this whole SOP situation again. So SOP. So same means the same as we had here. So we're adding. Opposite is subtracting, and plus for P. So SOP. Okay, so this is what it looks like. Pause, write these formulas down, take a screenshot, do what you gotta do. Okay, let's try a couple. So let's start with something that's just really nicely behaved. Let's say we've got x cubed minus 8, and we want to factor this. All right, first of all, we need to make sure x cubed is a perfect cube, and it is, and 8's a perfect cube. Now, if you take the cube root of x cubed, you get x, and if you take the cube root of 8, you get 2. So this x is going to function as our a, and this 2 is going to function as our b. So remember, we said a, b, a squared, ab, b squared. Same, opposite, plus. So what is a? We just decided that a is x. All right, so x minus b. b is 2. A squared. All right, well, here's a. It's x. So a squared equals x squared plus ab. So a times b. X times 2 is 2x. And then b squared is 4. That's it. You're done. That's what it looks like. That's as simple as it gets. Let's try another one. Let's go 8x cubed plus 27. Okay, so again, double check that everything's a perfect cube. 8x cubed, 27. So what is our a going to be here? What is the cube root of 8? 2, and the cube root of x cubed is x. And b, the cube root of 27 is 3. So why don't you pause and see if you can come up with this. Okay, let's see what we got. So again, I'm going to set things up. A, b, a squared, ab, b squared. Same, opposite, plus. Okay, a is 2x. B is 3, so 2x plus 3. A squared. Now, when you go to square this thing, you have to square the whole shebang. Did you do that, or did you just write 2x squared? Be honest. 2x times 2x is 4x squared. Be careful. All right, 8 minus a times b. Well, 2x times 3 is 6x. B squared. 3 squared is 9. That's it. There's your answer. Did you get that one? Because that one was a little bit tricky. Don't let it get you. Okay, let's try another one that's maybe even slightly more complicated. How about, eight's just so easy. Okay, 8x cubed plus 125y cubed. Okay, we have all perfect cubes. Find your A and find your B. Hit pause and try and factor this. Okay, ready? Your A is going to be 2x and B is 5y. All right, here we go. Remember, A, B, A squared, AB, B squared. Also, you don't need to memorize this formula. It's on the wall on a yellow piece of paper by the periodic table. And also, I will give you this on your test, but sometimes it's just easier. So same, opposite, plus. Okay, so that's going to give us 2x plus 5y. And then again, you're going to square 2x, so 4x squared minus AB. Well, if you take 2x times 5y, you get 10xy. No big deal, just multiply like you learned in middle school, or maybe grade 9. Okay, and then b squared is going to be 25y squared. 25y squared. Okay, that's it. Is that what you got? Okay, final situation. Okay, that's a lie. We've got 2 more. What if we have this? What if we have x to the 4th minus 8x? What's the problem here? Why can we not factor this with difference of cubes? Well, because x to the 4th is not a perfect cube, and neither, for the record, is 8x. But can we do something here to make it a difference of cubes? We can. What would you do? Did you answer? Okay, what would you do? If it were me, I would factor out an x. And then you would have x cubed minus 8, right? And then from there you could factor and you would get x and just put some giant brackets out with smaller brackets inside, right? And then you could be like x minus 2, x squared plus 2x plus 2, right? Oh, no, sorry, 4. My bad. That's what happens when I do things without formula, right? And then you just have this x factored out in front. So keep that in mind if you ever see something like this. Like ask yourself, is there a way I could make this work for me? Okay, this is the last situation. What happens if you got like this? Negative 125x cubed minus 27. What can we do with this situation? Well, there's 2 options. You could factor out the negative, right? What happens if you factored out the negative and then you had 125x cubed plus 27? Right? Like this would work. You factored out the negative and now you're doing sum of cubes. Or over here, you could just deal with the 125, right? And what would your a value be in this situation? Your a would be negative 5x and your b would be 3. So let's work that and see if we get the same thing. Okay, so we would have, remember, we've got a, b, a squared, AB, B squared. That's what we're working with. Okay, try these. Try them both ways and see what happens. Hit pause. Okay, let's see what happened. So you had negative 5x. Oh, sorry, we forgot to put in our operators. Same is negative, opposite is add, and then plus. So minus 3, and then you had, so negative 5x squared is 25x squared. And, ooh, this is going to be a problem. So if we multiply a times b, we get negative 15x plus 9. Okay, this is kind of what we have. Okay, now over here, let's come back to this side. If we factored out that negative, then we're going to have what? We're going to have 5x plus 3. And then 5 squared is 25x squared plus 15. Oh, no, sorry, because over here we're doing, oh my goodness, what a mess I'm making. Over here we're doing difference of cubes. So this, good gracious, somebody needs to correct me. This is sum of cubes, right? Over here we were doing difference of cubes. So sum of cubes, we're going to have same, opposite, plus. So this was 3. And then, okay, so 25x squared, and then you're going to have 5 times 3 is 15x, and a 3. I mean a 9, because I know how to multiply. Okay, and a 9. So my question is this the same thing as this? And it is, because here my negatives just factored out, right? Like I could factor that back in and get negative 5x minus 3 is 25x squared minus 15x plus 9. Okay, so you can kind of tackle those. You won't run into something like this very often, but you can tackle it however you want. All right, so moral of the story is this is a situation where it's great if you know what the formula is, but you need to know how to use it. Don't forget to square everything. So you have to square the entire A value and the entire B value. Okay, I hope that helped. Good luck.